It's the most advanced weapon in America's arsenal.
American supercarriers are the most powerful naval strike weapons in the world.
Now, a revolutionary new technology promises to give U.S. Navy supercarriers the speed, strength, and agility to dominate 21st century warfare.
It'll be able to meet future missions that we probably don't even know about.
Take an exclusive behind-the-scenes look at the Navy's game-changing carrier catapult.
And we're doing something that's never been done before.
And witness a history-making high-stakes test
System and final ready.
that will either launch the Navy into the future or deal a devastating blow.
If they cannot get this system to work, the very future of naval aviation would be in severe jeopardy.
The nuclear-powered supercarrier is the cornerstone of America's military might. A mobile combat airport with the power to project urgent and overwhelming force anytime, anywhere in the world.
Any day that the president wakes up and there is a crisis somewhere in the world, his first question is inevitably going to be, where are the carriers?
In a time of crisis, job number one is to get attack aircraft off the deck and into the fight. Launching heavily armed fighter jets off a 300-foot section of ship deck is a major technical challenge. It takes a boatload of mechanical muscle to get a 45,000-pound aircraft from 0 to 170 miles per hour in a mere 2 seconds. For nearly 60 years, the U.S. Navy has relied on steam-powered catapults to do the job. Today, engineers are hard at work developing a revolutionary new system called EMALS, the electromagnetic launch system for carriers.
In the 50s, when steam came online, it was the state of the art. It was a great system. They tried all other steam worked. Now it's time to move to the next phase, and electromagnetics is the way to go.
It's designed to be faster, smarter, and 30% more powerful than steam.
It'll be the most capable launcher out there in the world, and able to meet, future missions that we probably don't even know about at this point in time.
November 16th, 2009. Workers at the Northrop Grumman Newport News shipyard lay the keel for the USS Gerald R. Ford, first in a new class of high-tech supercarriers. The Ford is being built from the ground up to accommodate electromagnetic, not steam, catapults. It's a risky strategy, and the Navy is betting big that they can make it work.
But the EMALS team is under incredible pressure to bring this technology, which was just in the lab a few years ago, and put it on an operational carrier, which is, oh, by the way, already being built before the system itself has been properly and fully tested.
If the EMALS program fails, it might be too expensive to retrofit the Ford for steam catapults. The multi-billion-dollar Ford might have to be scrapped, and the Navy would have to go back to building the old Nimitz-class steam catapult carriers.
And were that to occur, the very future of naval aviation as we know it today would be in severe jeopardy.
But if the Navy can get EMALS to work on the Ford, the payoff could be huge. America's 21st century Navy is already straining the limits of the old-school steam catapult.
Going and launching off a steam catapult is like shooting an airplane out of a cannon. And all of that force is transmitted up through the nose gear to the rest of the structure of the airplane, and that can reduce the structural life of that aircraft by as much as a third or more compared to a conventional land-based aircraft.
And steam-powered catapults can only launch aircraft within a limited weight range.
The Navy would like to be able to launch a wider range of aircraft off of carriers than they presently do. This ranges from much heavier aircraft, up to 100,000 pounds, like maybe a transport aircraft, to something small, maybe under 10,000 pounds, that would be like a small UAV that requires a much more delicate launching.
The heart of the EMALS is the electromagnetic linear motor, the same technology that powers theme park roller coasters. A linear motor is basically a standard electric motor unrolled and laid flat. When a wave of electrical current is sent down the length of the motor, it creates a linear force. The Navy wants to use that linear force to catapult aircraft off the next generation of supercarriers.
The U.S. will be the first country to develop an electromagnetic aircraft launch system.
EMALS provides the Navy with a lot of things they want in a new carrier catapult. Safer, easier on the airframes, less operations and maintenance costs. All in all, it's going to be a vast improvement over the existing steam-powered catapults.
But first, they've got to make it work. Engineers at the U.S. Naval Air Systems Command in Lakehurst, New Jersey, have built this full-sized, fully functional, land-based model of the EMALS. The linear motor sits beneath this 360-foot section of runway and pushes the aircraft launch shuttle down the length of this slot.
Launching in 3, 2, 1, fire.
Here they can test and refine the system by running simulated launches, using weighted sleds known as deadloads.
So as the aircraft is being accelerated down the track, we can very accurately control the velocity and the force that's generated by the linear motor.
Ready to retract on your command.
That tight control means EMALS can launch both lighter and heavier aircraft than the old steam system. And the EMALS is programmed to provide a smooth, even acceleration that engineers say will be easier on the aircraft. But developing this sophisticated system has not been easy. Delays and cost overruns have put the EMALS program $1.3 billion over budget and 7 months behind schedule.
Every day of construction on the Ford means that much more time, money, and material going into a ship that is dependent upon EMALS successfully functioning. The team knows they have to make this work.
For now, the Lakehurst team is under the gun. The U.S. Navy has a long history of building ships and systems that push technological boundaries. It's a bold strategy that ultimately produces the most capable
In the Navy.
The modern supercarrier is one of the most complex and technologically advanced pieces of engineering on Earth. It's a critical component of America's military might. The USS Ronald Reagan is one of 10 nuclear-powered Nimitz-class supercarriers, the largest warships on the seas today. Its primary mission is to launch and retrieve to massive pieces of metal. You can't ignore the two 30-ton anchors. They're attached to huge chains over 1,000 feet long, with links weighing 365 pounds each.
This machinery up here is the Wildcat. This is connected by the windlass, and this is what spins to raise and lower anchor chain when we're anchoring or getting underway.
The heavy chains sit in an area called the forecastle, passing through the deck down to this storage area.
Right now we're in the chain locker, 3 decks below the forecastle. From here all the way to the bottom is 50 feet. We keep 1,000 feet of chain stowed down here in the chain locker.
The anchors, the chains, and the machinery to move them are truly enormous, like just about everything else on this supercarrier. The modern supercarrier is a mobile combat airport, with dozens of highly trained pilots flying the Navy's most versatile strike fighter, the F-18. These powerful planes require explosive weaponry to complete their missions. So ships like the USS Ronald Reagan are packed with 10 million pounds of ordnance. On board the carrier, the air wing includes 7 squadrons of more than 60 planes and nearly 2,000 sailors. Most crew are in support roles. Only 100 are pilots, separated into tightly knit squadrons of 10 to 15.
Typical pilot in the air wing who flies these F-18s, for example, is going to be a lieutenant, mid to late 20s maybe 30 years old.
We're launching aircraft, catapults 2, 3, and 4. Stand well clear. Shoot them up.
The F-18 Hornet is the heart of the air wing. It's the Navy's top strike fighter aircraft, thanks to its reliability and performance during combat. The F-18 is a versatile aircraft. It can easily switch between attacking targets on the ground and targets in the air.
If you're going in to attack a target and you have to defend yourself against enemy aircraft on the way in and on the way out from that target, the Hornet can do that. And it's an extremely pilot-friendly aircraft to fly.
The Reagan's Air Wing has 4 squadrons of F-18 jets, almost 50 planes in all.
Their primary function here is overland strike projection. That's really what the carrier is all about, being able to project force across the horizon.
The Reagan has 2 carrier-based F-18 models, the $29 million Hornet and the latest version, the $57 million Super Hornet. Measuring 60 feet 4 inches long with a wingspan of 44 feet 11 inches, the Super Hornet has a top speed surpassing Mach 1.8. More than 1,300 miles per hour. With that kind of speed at their disposal, these planes can create a sonic boom as they easily fly past the sound barrier. The F-18 Super Hornet carries up to 11 pieces of ordnance on every flight, attached to hooks on the wings or body of the plane. Some weapons are guided by GPS, radar, or heat-seeking infrared, like the Sidewinder missile. Others are simply dumb bombs, heavy, unguided explosives weighing between 500 and 2,000 pounds. And then there's the Hornet's powerful gun, a 20-millimeter cannon that shoots 6,000 rounds per minute. Every piece of the ship's ordnance is kept in one of 34 storage units, called magazines. Flight preparation begins in a well-protected assembly room deep inside the carrier, 5 decks below the waterline. Here, unarmed weapons are assembled for combat by a well-trained crew of ordnance handlers, known as the G3 Division. The crew is preparing a 500-pound Mark 80 series unguided dumb bomb. On the bomb's back end, an aerodynamic fin is attached. It'll help the bomb fly more accurately to its target. At the same time, a nose plug is installed on the front end to give the bomb greater target penetration. The crew adds a safety switch and inspects the bomb. A pneumatic hoist moves it from the assembly table to a skid for transport to the flight deck. This well-trained crew is efficient, completing the ordnance assembly in about a minute. One of the ship's 9 ordnance elevators brings the bomb to a staging area, or bomb farm, located on the flight deck's starboard side. After one last inspection, the G3s hand custody of the bomb to the squadron's own ordnance crew. They'll load the weapon onto an F-18. There's no room on the flight deck for pneumatic hoists, so this 6-person team must lift the bomb by hand and carefully lock it into place on the F-18's wing. For leverage, they use metal poles, nicknamed hernia bars.
Forward! Forward, straight up! Left forward! Lock down, shake it! Hook support weapons, 20 braces in and inboard! Up forward!
Finally, the bomb is safely locked and tightened into place. At this stage, with the dumb bomb tightly attached to the plane, the crew can arm it for combat with an exploding fuse. Carrier flight operations require intense concentration and focus. Add the element of darkness, and you get one of the most challenging and dangerous forms of naval aviation: nighttime flight operations.
It's something that a lot of people never really get used to. I don't think the Wright brothers would have invented an airplane if they had flying at night in mind, especially off of an aircraft carrier. It's not something that's necessarily fun, but it will get your heart beating.
Many combat missions are flown under cover of darkness, so aviators must also train this way. Yet at night, no horizon is visible, and pilots can easily lose a sense of their surrounding space.
On an exceptionally dark night, which we'll have when there's no moon or when there's weather above us blocking out the moon and the stars, it can be very disorienting.
During a landing, pilots shift their focus to the flight deck's meatball to guide them in. Yet they often don't realize how close they are to the carrier. And the touchdown can be a jarring surprise.
It can go south very quickly when you're landing on the carrier at night. You just revert to your training and don't think about it. If you think about it, you're going to be dead.
Just about everything that happens on a supercarrier depends on a reliable, high-volume supply of electricity. Only the planet's most powerful energy source will do. All Nimitz-class carriers are powered by 2 nuclear reactors embedded deep in the ship. The reactors are highly classified and heavily protected.
It's built to go into war, so it's surrounded by lots of steel and then some more steel. It's much more rugged than a commercial shore-based power plant.
Inside the reactors, uranium atoms split apart in a controlled nuclear fission reaction that releases energy to heat pressurized water. The extremely hot liquid then passes through a heat exchanger, producing steam to drive a turbine, spinning a generator to produce the ship's power. The high-pressure steam also runs the catapults, and it powers giant turbines deep inside the ship, turning massive shafts and rotating 4 enormous bronze propellers. At the back of the ship, 2 huge rudders weighing 50 tons each handle the steering.
We have 2 reactors on board the ship. One reactor can pretty much do all the things we need to do on board this ship. So having 2 reactors provides us some redundancy and some flexibility.
The Reagan's reactors and turbines also provide electricity to power the entire ship, from radar screens to the hangar bay doors to the aircraft elevators. Altogether, it's about 64 megawatts, enough electricity to supply a city of 100,000. And the reactors are designed to run for more than 20 years before replacing their uranium fuel. Now, the Navy plans to use concentrated energy from the ship's reactors to power their revolutionary electromagnetic aircraft launcher.
Launching in 3, 2, 1, fire.
Engineers at the Naval Air Systems Command in Lakehurst, New Jersey, hope to prove that the EMALS catapult can give the Navy safer, faster, and more efficient carrier launches. Redesigns and malfunctions have put the program 7 months behind schedule and $1.3 billion over budget. As a multi-billion-dollar supercarrier is being built around the electromagnetic launcher, the EMALS team is under the gun to show their system is up to the job.
It's been an interesting challenge developing the system, qualifying the system, making sure that the Navy is comfortable with the analysis we've done, and then of course the testing is all about confirming the analysis.
After running more than 1,000 dead load tests, it's time to take it to the next level.
At this point, it's time to give EMALS its ultimate test, hooking a $50 million F-18 up to it, putting a man in it and letting him ride it into the sky just as if he was flying off the end of an aircraft carrier.
Navy test pilot Lieutenant Daniel Ratichai, call sign Butters, will be the first person ever to attempt an EMALS launch.
Test pilots all want to be the first guy to test a new system, so as soon as I saw it coming, I was like chomping at the bit to be the guy that got to do them the first time.
December 18th, 2010. The EMALS development team is preparing to make naval aviation history. In just a few hours, they plan to do the first ever electromagnetic launch of a manned aircraft.
And we're doing something that's never been done before, so you can't really say it's routine. And as soon as you feel like it's routine, you let your guard down, and that's when something bad can happen.
It's a very stressful day coming in and starting safety briefs, although it is the most exhilarating feeling you can have as an engineer, to finally see everything coming to fruition.
As they wait for the morning fog to clear, all hands do a FOD, or Foreign Objects Debris Walk. They scour the entire length of this 12,000-foot runway, picking up anything that could get sucked into the engine during the test launch. The sun finally breaks through the cloud cover as the test pilot touches down on the Lakehurst runway. Lieutenant Daniel Ratichai is no stranger to catapult launches. He's been flying F-18s for more than 7 years, and he's got over 400 steam catapult launches under his belt.
I'm able to give him a pretty detailed explanation of you know, seat of the pants feeling during the catapult shot.
The first manned EMALS launch was supposed to happen several months earlier. But setbacks and design changes have put the project behind schedule and over budget. The Navy is betting big that EMALS will be ready to install in the Gerald R. Ford, a new supercarrier already under construction. Today is the team's chance to prove their system really can work as advertised.
There's a lot at stake here. The viability of this program is being tested by going and risking a $50 million combat aircraft and the life of a very talented young pilot to go ahead and prove whether this system is good enough for the next 50 years or not.
With just minutes to go until launch time, the crew attaches the F-18's nose wheel to the EMALS shuttle. On this test, there's no margin for error. Everyone's got to stay on their toes.
My biggest concern today is if something were to go wrong with one of the engines, you know, I might not have enough speed to fly away, and it puts you in a bad position.
There's a lot of things that could go wrong, but obviously it's very stressful when you have a man on there that, you know, you have to feel personally responsible for.
Inside the bubble, the shooter stands by.
Right now I got 2 yellow shirts up on deck. The green perennial yellow shirt is my safety. He takes control of the actual launching of the aircraft. He lets me know that the top side is safe. He'll salute the pilot and he'll give me a thumbs up. When I see that thumbs up, I'll do my checks and I can launch the aircraft.
The pilot gives the signal, and the test is on.
System and final ready for 70 knot, 31K deadload.
It all comes down to this moment.
Launching in 3, 2, 1, firing.
Launch went great. Everything was as expected. Parameters went good. Plane got off. Everybody did a great job.
About halfway through the stroke, you know, you got a general idea that things are going well. You feel the G-force and you feel the acceleration. You know things are somewhat working. When you feel those wheels leave the earth, that's kind of when you know that it was successful.
A launch is something you don't just watch, you feel. It just goes right through the core of you. You feel the rumble, you feel the plane go off, and that's a good feeling.
The first electromagnetic catapult launches are a success. The system will still need some fine-tuning, but after today's launch, one thing is certain.
This successful test is a really big moment for the EMALS team. They've proven the system works. The questions that there have been about the viability of the system have been generally put aside, and they're now ready to go into the larger, longer portions of the test program to get it ready for installation.
Over the next few months, the team demonstrates the reliability and versatility of the EMALS as they conduct dozens of successful launches. The first shipment of EMALS components is delivered to the Newport News shipyard in May of 2011, putting the Gerald R. Ford on course to be the world's first carrier to launch aircraft